Yeah, this next talk is from DR Sadi. He's going to discuss about an oldie, MBR bootkits, but still interesting nevertheless. The talk is called Master Boot Record Bootkit Analysis and Reverse Engineering. The floor is yours, DR.
Assalamu alaikum, everyone. Thanks for having me today. Well, actually, I have decided to make this research paper because there are a lot of talkers from the Google, from the internet, that's not straightforward for the beginners. You may try to find some kind of a bootkit or MBR, master boot record analysis, but actually it's not a beginner level. It's a quite advanced using a debugger or using some kind of the tools that may it's not a easy and straightforward for the beginners. So this talk is actually for beginners, for those people that don't have any background on the bootkit analysis or MBR analysis. So I hope you are enjoying it and learn something from my presentation. Well, a brief introduction about me. I am Dr. Sadi Ali from Kurdistan, Iraq. I'm 24 years old, also computer security researcher from 11 years old. I have already spoken in many international conferences, such as Black Hat MEA, VolunCon, COSAC, B-Side Budapest, and so on. I'm also one of the contributor of CVE 2026 2841. I think it's a Notepad RCE. You can check for MCRC knowledge section for that. Well, the first question and one of the important question is, what's bootkit and why bootkit? Well, in the simple term, actually, bootkit is a malware that infected the boot process, MBR and UEFI, to run before the OS. So that's mean when your computer gonna infected by bootkit or MBR, master boot record malwares, it run before the OS, because actually in a normal state, when you run the computer, after a few seconds, you just maybe see a Windows logo or maybe a Linux logo and so on, or maybe the Apple icon. But actually when your computer gonna infected by a bootkit or a master boot record, it's override your sector 0, the first 512 bytes. It will show other stuffs, maybe show the ransom notice, maybe just show the error messages, okay? And the second ones, to gain persistent and detected access. Well, actually detecting bootkit or MBR malware is not easy as a normal malware. Maybe if you try to detect a Trojan, remote access Trojan, try to detect a crypto miner, try to detect info stealer, it's quite easier. It's quite easier. You may just try to check for startup, registry, task schedule, updata, and other directories. But actually, in a bootkit case, you don't have this, because actually, the bootkit have a privilege to work at the ring 0, the high level. It's okay. We have a bootkit, we have a rootkit, we have an MBR malware that work in a kernel land and work in the Linux land. But mostly they are work on the ring 0, so in a high privilege. And actually, you cannot able to detect that through a traditional antivirus product like a Windows Defender or so on. And the purpose of the bootkit is for hiding the malware and maintain control of the system. Okay, that's one of the reasons, because actually, when you infected by a normal malware, even the sophisticated one, it may just stay for a while, not for years, not for decades. But actually, because of the bootkit functionality, you don't have a good detection toolkit to indicate that your computer is infected by a bootkit or MBR infector or not. And actually, it's hard to detect it. It's not something easy. You can't spot it. Maybe you will spot it if you restart your computer. But at this case, you have to be infected by MBR Locker. MBR Locker actually is a type of the master boot record malware that asks for the key to start loading your operation system. Okay, so I believe that to indicate that you are infected by a ransomware, by the wiper, or by the crypto miner is a more straightforward than a bootkit and than a rootkit also, because as you know, the rootkit is manipulate DKOM, direct kernel object manipulation. Okay, and actually there are no specific tool, as I mentioned earlier, to detect the bootkit on your device. Maybe only if you are quite smart to use hex editor and loading your hard disk and check for the first sector, and then it's maybe show you some kind of the indication that you are infected by a bootkit. Okay, and actually one of the significant is threatened system integrity and sensitive data, and early detection is crucial. But actually, in this case, early detection is quite impossible. It's quite impossible because, as I mentioned earlier, it don't show you any sign. Even it doesn't make your computer slower because it's not a crypto miner that using your device for a mining purpose. Your computer is look like a normal. Your computer is fine, but actually behind the scenes you are infected by the bootkit. Well, what's a master boot record, MBR? So actually, it's a special boot sector at the beginning of the storage device that contain a bootloader, okay? And the bootloader partition is 0x18 and contain the partition information. And actually, the MBR is in a sector 0, so the first section of your partition or of your hard drive. And actually use it by a system to start the operating system and manage partition, okay? Usually, when you turn on your computer, first of all, the electric move into your motherboard, and then a post-operation start to checking your computer or the hardware. There are no issues, and then the operation systems copied from the room, read-only memory into the RAM, and actually the bootloader start loading by winload, and the winload start loading NTS or kernel, and then the operating system start. And you see the login UI.exe, and then when you enter the password, the lsas.exe comparing your credential, and then explore.exe, the graphical user interface that's you in the Windows. That's all the sins actually. And in the MBR, in the master record case, when you turn it on your computer, actually you just maybe see a ransom node, as I mentioned earlier. And the purpose of MBR, actually, it's initiates the boot process and tell the OS where to load from. And actually, it's crucial for the system startup and any corruption that prevent operation system from booting. So if there are any issues from the hardware, actually, the post-operation tell you. But actually, if there are any problems on your bootloader, on your sector 0, your computer may be not booting actually. And also, one of the significant stuffs here is protecting the MBR is essential for the system integrity and data access. Okay, if the threat actor is swipe your MBR, there are no operating system to load. Okay? And here a great chain that how the master boot record work. Well, first of all, the BIOS, basic input and output, or UFI loaders, power on the POS. Well, the POS is an operation that checking for any errors on your hardware, on your device. For example, when your BIOS time zone or timestamp is in a 2000 or in 2007, your computer show this error, tell you check the date and time and fix it. Then you can use your operation system. Okay, that's a first stage. And the second stage is reading the MBR. basically sector 0. So the BIOS, basic input and output, read the first 512 bytes from the dissect, and the address of the MBR loader, master boot record loader, is in address 07C00. Oh, sorry, 07C00. That's a memory address of the bootloader that are loading master boot record. And actually, in a next stage, the CPU, the central process unit, jump to 07C00 and run MBR code signature, and that's 0x55AA. Okay, that run the signature, and actually after that they read a partition table. So actually we have a partition table, and that's essential to the operating system, and read at least 64 bytes from the master boot record and find the bootable partition signature and flag, you can say, is a 0x18. And in the final stage, that we have in the slide, that load VBR and OS loader, so load volume boot record from the partition and transfer it on the control operating system. Okay, and actually we have other stuffs here. When winload.exe that load master MBR, they are also loading the boot configuration, BCD, boot configuration data, that contain an entire configuration about your operating system, how the registry or registry hivers contain the information about your entire OS, entire activities from your device. Well, how the infection chain is worked? Well, we have a many infection chain. For example, for a normal malware or for sophisticated one, the attacker send you a link or send you a phishing mail, or maybe using initial access broker IAB, or using credential harvesting and brute force and supply chain attack and so on. But actually how the Bootkit infection chain is worked, that's very important to know about the infection chain. Well, first stage here is gain raw disk access. Well, if the malwares need to write the first sector of master boot record, actually it needs the privilege, it needs administrator privilege. This operation cannot be done through a user privilege, okay? Because basically you have to access the physical drive on your source code, and it's not happened by a normal state, okay? It's like how if you try to change the permission on the same file in your C drivers, you have to use the ICAPs, okay? And for this utility, you need to the administration level, administration privilege. So the first stage malware trying to do is gain privilege to write the dissect. So maybe it's happened by many ways. They have maybe a specific technique to bypasses user access control, UAC, or maybe try to run the sample on the software that binded with the malware, trojanize it with the administration level. Well, actually in the normal malwares, maybe InfoStealer or any kind of the crypto miner, just run as invoker. So run as invoker means you can run the malware in a user land as a user level, and you can also run the malware at the administrator level, okay? And the second stage is a very important, actually, in the MBR malware or in the Bootkit infection chain. Well, the ransomware functionality is encrypting your file. That's a clean and that's a crystal clear. But again, ransomware also get a backup of your data, get a copy of your data. And the MBR also get a copy of your MBR, get a clean copy of your master boot recorders, and then start writing their malicious patterns into the master boot record. Okay, because actually, there are many ways to recover your operating system from the master boot record malware, as I will talk about later. That maybe be useful for your company, for your organization, and for yourself also. And the third stage is write malicious bootloader, override the MBR at the sector 0 with the bootkit, okay, with their data. And actually, in the stage 4 is hiding payload on the dissect. So there are two ways. Actually, there are two ways. The first one, store the bootkit body in an unused dissect sector, and the second one in a hidden partition or slack space. Well, the slack space, it's an empty space at the end of the file. Okay? And the final stage is run before OS loads and persist across the reboot. That's one of the interesting points. Actually, when your computer is in a clean state, when you turn on your computer, something came into your screen, and then Windows logo appear or Mac logo appear, and then you, a normal user, start your working day. But when you're infected by an MBR or MBR overrider, you just see a ransom screen. And that's a clean example, MBR before and after bootkit infection. Well, in the left side, we have a normal computer here. There are nothing in a sector 0, okay? There are nothing that look like suspicious. But actually, when you look at the right side, there are something blobs here, like valid partition table, error load operation system, and so on. That's one of the point you can detect that your device is infected by MBR malware or bootkit, because usually it override your sector 0 as appear here. And actually, there are another screenshot to determine that how the ransom node is work in an MBR infection chain. Well, again, in the left side, we are in the clean state, but in the right side, we are in an infected state. So MBR message, if you are looking at the message, then you must have misread the steps. No, there are no way to boot your computer and so on. Okay, that's a clean message that you are infected by MBR. As we mentioned earlier, if you're infected by ransomware, your screen background is changed, the README or the ransom.exe or the notice text written into your desktop, and then you know and you notice there are something suspicious. But in an MBR, there are only two ways: check the first sector using hex editor or restarting your device. But do not restart your device, because actually you don't. Oh, you can't boot it again and change it into the normal state. Okay. Well, there are infection chain actually. That's it's a MBR malware that designed for destructive or sabotage purpose. Okay. So there are no way to loading your system again at this stage. So we have two types actually on the MBR and the bootkit. One of them is destructive, like a wiper that wipe your operation system. Actually, wiper needs the administration privilege to delete your system file, like a bootkit to override your physical hard drive and the sector 0. And there are master boot record locker. Okay, ask for the key, need the password, and so on, as you can see from the screen. So warning, because you don't study well your computers, lock it, want to decrypt it, please study well, blah, 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 and contact me to get a decryption key. Well, so the first of all, to analyze the bootkit, of course, the first stage is a triage and then static analysis. Well, this bootkit sample are signed, okay, from the I think name of the signer is semantic time stamping service signer. Okay, I think this signature has stolen. And then from the metadata analysis, there are some readable screen that, some readable text that you can get a benefit on it. For example, it's a Windows GUI. It's a Chinese simplified, and some blob pattern is that is not easy to read. Well, and file permission, write, read, execute. So it have a 777 permission, entire permission of the operating system actually.
Hey,
and
sorry, can you hear me? Hey,
yes.
you have 3 minutes left.
Really? Oh, it's very okay.
You have 50 slides, and you have 2 minutes left.
Okay, just try to.
We have a problem. We have a problem clearly. So you have to conclude in 2 minutes. So yeah, we have a problem.
Okay.
I'm sorry, but you are in the introduction, and you have 2 minutes left.
Okay. I will try to do my best here. So actually,
it's not possible.
So I will do my best. Well, actually, in this stage, we are trying to investigate the import address table, the APIs that malware uses. Actually, some of them that using a native APIs, and some of them using a normal APIs, like here, virtual alloc, read file, write file, and copy file, and get shared path, and so on, and also the copy file. And I don't know why Bootkit using a reg close key and reg open key, because it doesn't need any kind of the persistent. Well, actually, it's a stack string. Well, in the same cases that malware author trying to put their strings into the stack, because tools like bin text, tools like string utility from the sys internal suite cannot detect the stack string. Okay, in this case, you have to using the tool like a Flosses. And actually, it's a beeps.sys file. I think it's not important in our case at the now, because we only have a 1 minute maybe. Well, we are trying to reversing this bootkit through the IDA. As you know from here, trying to do a dissect enumeration and get the first sector here, okay? And actually get the physical drive 0, and then trying to write the first sector. Okay, trying to write the first sector. And actually, at this stage, the attacker trying to use utilities and the files to communicate with the hardware. As you see, the beep.sys, actually. Well, the self-destroy mechanism, one of the interesting stuff at this sample is having self-destroy mechanism. When you run once, the sample guns, even if you use the OS query dissect enumeration, you cannot find it. Okay, so it's gone. Well, actually, in this case, the boot sector, the master boot record trying to read and write the boot sector. Okay, so here pushing the 1200. That's a size of the master boot record, and trying to write on it. As you can see here, number of byte to read. So 512, and then write file. Okay, on the physical drive. And then at this stage, there are some MBR, some master boot record that designed or developed in a C or C++, but we have something that developed by C# or a Visual Basic. At this case, trying to create a file and get access on the physical drive and writing the MBR size 512 bytes. And in this case, we have in a memory forensic, I captured the RAM through dump it and start investigating the processes under the string. Well, actually, processes is a useless at this case, because as I mentioned it have a self-destroy mechanism. So there are no process live at the operating system. And you can try to use a Yara in the volatility to check for the strings inside the process. And actually, it's a reversing in the action. Well, I think I'm gonna done now. Well, at this stage, I found the password through the string analysis. So if you a malware analyst or reverse engineer, focus on the string, because actually you find a critical information at this stage. Well, there are something that connect the dots together. Your dissect have a lock please input the unlock password. And done. And we have a physical drive. But here's something interesting. BLU and 60 MB. So actually I tried this key and then the computer is turning on after the lock it by MBR infector, and they are a connection to the string. So actually there are X reference for the string. You just have a locket, please input the unlock password, and there are some functions here. And actually this string is called by this function. So that's connected to here. And finally I have able to unlock the device. And if you have any questions, feel free to ask it, and I am done.
So maybe
Thank you. Thank you.
Okay, thanks.
Yeah, it's unfortunate we can't take questions. We already ran out of time. But yeah, see you next time. Yeah, thanks.
Bye.
Bye.
Bye. Love you all. Have a nice time. Assalamu alaikum.